Welcome to my YouTube channel where I share with you my journey towards data science. Hello, my name is Idalia, and as you know, I've been sharing with you my pathway towards data science. And the project that I'm going to share with you today is a project that I've done for mid 1 month and a half into my data science bootcamp. So we are mid-February 2023. So this one was very special. I really enjoyed doing this one. It was the dataset of Titanic. Everybody probably knows that is currently doing an introduction to data science. That everybody does these types of projects. And I really love this project. Maybe because when I was 10, 12 years old, Titanic movie came up. It was, a love story in the middle of a disaster. But I think the way that was designed, the movie was so really touching and special. And, a love story always really, resonates really well with me. So I really enjoyed it. And maybe that's why I had some kind of special feeling about it. And I also visited Belfast, where Titanic came up, and that's why I think it resonated quite a lot with me, and I want to share with you the results. I really enjoyed it. It doesn't have too much complex things that I've done, but I want you to share some of the things that I've done so far. I hope you enjoy it. Alright, so here I am to show you the assignment that I've done for the week and a half in the data science bootcamp, and this was with the Titanic dataset that everybody probably uses. And I want to know if you live or die, so it's to check whether you would survive or not survive. So as always, looking at problem, time, solution, explore the data, prepare the data, and shortlist models. So could it really predict your luck of survival in the Titanic? Well, to do that, we did some basic descriptive statistics, and we applied some regression models like the logistic regression, naive Bayes, and decision trees. So first, we extracted and explored the data. We imported out all the libraries as we went along, import the data files. Actually, this one had 3 data sets, which was gender, test Titanic, and train Titanic, which was a little bit tricky in your head when you do it for the first time on how to actually set up your variables, and independent and dependent variable I found. But also as well, because the test Titanic didn't have survival, we had to input the survival from the gender, and it was a little bit confusing. And I'll show you why. And then we did some just looking at the data basically. Then we treat missing data, so we've used the medium and the Filina to kind of input the missing data from the age, because we didn't have normalized data. And also, we also did replace the values of fare on the testing data, but because our cabin had a lot of missing data, we treated differently. What we did was to create a new variable called deck and replace all the missing values with unknown, and extract the letters, which is the cabin place where they were, instead of the numbers, and just extract that. Maybe perhaps that would give us an idea whether or not, if you're on a high class cabin versus a low class cabin, you have more, or maybe the position on the boat. Maybe that would give you a general idea if you would survive. Then we did some descriptive statistics on the train data. So we could see that the average passenger were 29 years old. The median was 14.45 per ticket. We could see that older men were more common compared with women. And we can see that the high proportion of younger passengers were third class, which is quite interesting. Then we could see that men were more likely to have died than women. I think that's because, as you know, on the movie, if the movie is actually true, women had priority over men on the boats, which maybe the reason why we had so many mortality among men. And then I did some kind of pair categorical plots to see if there is a survive plus was different. First class tended to survive much more than the second and third class, but not really that different. But men and female was quite a huge difference. And the other ones is difficult, but apparently the G deck where everyone survived. We looked at the correlations. We didn't see any significant correlation, but I think we could have done better. So then we did logistic regression, naive Bayes, and decision tree. Initially, I found that really weird. We predicted survival by accuracy of 100%. I thought, something has to be wrong to have an accuracy of 100%. It can't be. So how come? So what I did to try and understand that was to plot the logistic regression chart on the train and test data. So as you remember, I had to extract the gender survival outcome into the test data because we didn't have that outcome there. But that coincidentally plotted all men as died and all women as survived. So that's why we predicted 100%. So yeah, there was a problem. So what I did instead was swap my train data. I split it into test and train data, and there I could have a more prediction that was more acceptable, where we could predict survival by an accuracy of 78%, and that made more sense. So I was actually more happy. And then we did some naive Bayes because they deal better with small data sets and we could get the same results. And this was model survive based on sex. And ensure how to say, I don't know why did I get the same results as logistic regression. And then we did some decision tree models, decision tree, which is a fast and efficient and works with all kinds of data, both numerical and categorical, discrete and continuous. So I thought, but here I had a prediction score of accuracy of around 70%. Here I used all variables rather than just one to try and predict. Maybe more variables have less input in the mortality. As we see, gender tends to have high effect. Perhaps, using all of them doesn't really tell us more. So I thought that was interesting, and this is that's it. So yeah, assumptions. Well, 0 means survival, no survival. Test data probably is not representative. We had to we had to break the train test data into the test and train data, as I told you, and survival data was based on another column, which might not be representative. So really, I had modeling results had really average results, and naive Bayes and logistic regressions were really the best models. I have to assume that I have to learn that I should have started early and spend more time on the modeling. I underestimate the time it takes. So, as you know, we have a week to do this, and we learn the models by day 1 and 2. So we have, in essence, what I did. Started on probably Wednesday to present on Friday. So I had Wednesday and Thursday. On Thursday at 10 o'clock, I was doing the models. I don't advise anyone to do that. Maybe now I need to start on Monday, do the descriptive statistics, and by Tuesday, start on the model. And if I had more time, I would learn how to transfer variables from numerical to categorical and categorical to numerical, and test other variables, and more time to read and learn about how to pre-process the data. And there you go. Thank you so much. You can check my code on GitHub, on Kaggle. So I hope you enjoyed it, and if you have any tips or if you've done this exercise before, please share with me on the comments below. What have you found? What difficulties have you found? And do you share the same difficulties that I did or not? I hope you enjoy the rest of your day, and thank you for listening.